Thank you. Good morning to all. Welcome back to CMOS Analog IC Design. It's lecture number 13. And last class, what we have been discussing. Anyone? யார் அது? Surya Prakash. Yeah. My screen visible, right? And I'm audible, right?
Yes, sir.
Okay. We have been discussing feedback amplifiers. Feedback amplifiers. Based on sampling and mixing, based on sensing and returning mechanism, right? My sensing mechanism or otherwise sampling, two type of sensing mechanism. One is called voltage sensing, another one is called current sensing. And coming to returning mechanism, either you can return voltage or you can return current. Okay. Sensing. If you want to sense voltage, how will you connect? Will you connect in parallel or series? You want to connect in parallel. To sense current, you want to connect in series. That you know how we are connecting voltmeter as well as ammeter. How to return voltage from KVL, right? It says in order to return voltage, you want to connect in series. In order to return current, you want to connect in parallel. So based on these two sensing and returning mechanism, we are having four type of feedback topologies that we know. Very first one, right? Voltage series feedback amplifier. And simply I am writing voltage series feedback amplifier. What is the general diagram for this? So all amplifier, it may have some basic amplifier. This is my basic amp, feed forward amplifier, and this is my feedback amplifier, nothing but feedback network. Feedback network. This is my basic amplifier, right? Let me try it here. This is my basic amplifier. This is my feedback network. Simply it consists of series of resistors or one resistor. Always you want to connect this guy, load resistance RL. Now voltage series, how to sketch? So output is voltage mixing. So voltage mixing means this is my V out. So you want to connect in parallel, that you know V out plus minus, right? Yeah. So plus 2 plus minus 2 minus. Okay. Coming to input side, series mixing. So series means you want to mix voltage. This is my voltage source Vs. Right. So seriously, you know how to connect this, right? This is my, since this is voltage, so here also it is voltage Vf plus minus. So it becomes Vi plus minus. Okay. So here what is the gain for this basic amplifier? The gain, output is voltage, input also voltage. If you want, you can name it as A sub V. Okay. What is the feedback factor beta? Output is voltage, input also voltage. Now can you sketch the remaining four? The next one is voltage shunt, feedback amplifier. Please sketch by yourself, practice. It will give a lot of insight. That's what I'm sketching all these things. This is my basic amplifier, roughly I'm sketching. And this is my feedback network. right? So this time no change in sampling. Okay, so RL V out plus minus, since my sampling is again voltage, this is my V out plus minus. So V plus 2 plus minus 2 minus, but this time change in returning mechanism, change in sampling. This time I want to give current as input, right? So here you want to take current as output, I F, right? See, so this is my current. So IS, right? You know, this is my II. So it has to be divided. This is my IF. Being written out, right? So what is the gain here? Output is voltage, input is current. So this you may call it as R sub M. Okay. Feedback, output is current quantity, input is voltage quantity. Now coming to the third one, this time current, right? Current sampling, series mixing. So current series feedback amplifier. Okay. My basic amplifier. Roughly I'm sketching you please. So this time current series. So output is, you know, this is my current, right? RL is my I out. So we are giving this I out. Input is, you know, series mixing. So series means you want to go with voltage source. Once if you here it is voltage, so here also you want to take voltage VF, and you know how to connect this. This is my VI plus minus Vs plus minus. So here the quantity, output is current, input is voltage. So this you may call it as transconductance GM. Here beta, output is voltage, input is current. If I did any mistake, please let me know. Then coming to current shunt. Practically, we won't use current shunt everywhere, anywhere. No. Please make a note. Practically, we won't use current shunt feedback amplifier. It has less application when compared to the feedback topologies. Okay, so this is my basic amplifier, and this is my feedback network. Coming to output, this time current sampling. So you want to connect in series RL I out. This is my I out. Shunt mixing. So this time you want to play with current source. Here if it is current, so here also you want to take this current, right? IF. So IS has to be divided, right? This is my, you know, IF in this direction, IS. So here this quantity, this output is current, input also current. So this you may call it as A sub I. Beta, output current, input also current. Okay. So any doubt in sketching these four basic topologies? ஏன் இவ்வளவு கஷ்டப்பட்டு வரைஞ்சிட்டு இருக்கேன் அப்படின்னா வெரி இம்பார்ட்டன்ட். ஓகே, ஸோ ஐ ஹோப் ஸோ இதுல டவுட் இருக்காதுன்னு நம்புறேன். சரியா? கேன் ஐ மூவ்? சரி சார். ஓகே, கொஸ்டின் கேட்டிருந்தோம் இல்லையா, இன்டர்னல்ல கேட்டிருந்தேன். வாட் இஸ் தி கெயின் ஆஃப் யூனோ வோல்டேஜ் சீரிஸ் ஃபீட்பேக் ஆம்பிளிஃபையர்னு. அப்படின்னா கெயின் என்ன? வோல்டேஜ் சீரிஸ் ஃபீட்பேக் ஆம்பிளிஃபையர். So voltage series feedback amplifier, it's very simple. Output is voltage, series mixing, input also voltage. So you are getting V out by VI, right? So what is the unit? Gain. No unit. So here no unit or unitless. Similarly for current shunt, both are same quantity. Output also current, input also current. So here also no unit. நம்ம என்ன நினைச்சிட்டு இருக்கோம், கெயின் அப்படின்னா யூனிட்லெஸ் அப்படின்னு நினைச்சிட்டு இருக்கோம்ல. சீரியஸ் அப்படித்தான் நான் நினைச்சிட்டு இருந்தேன். பட் இங்க பாரு, வாட் இஸ் தி unit, okay, of the gain of voltage shunt feedback amplifier. So this time output, okay, current, but input, sorry, output voltage, input current. See this, but here the unit is, ohm, since it is resistance, trans resistance, right? So here the unit is mho. But we want to be clear, நம்ம எப்பவுமே இதுவரைக்கும் நம்ம பார்த்த கெயின் எல்லாம் எதிர் கரண்ட் கெயின் ஆர் வோல்டேஜ் கெயின் போத் ஆர் யூனிட்லெஸ். But here, okay, for voltage shunt as well as current series, you want to be very careful. Okay, the unit is different. For voltage shunt, the unit is resistance. For current series, the unit is no resistance. Okay, but what it indicates, for voltage shunt feedback amplifier, the input is current. Suppose I assume my gain is some 5 ohm. Okay, and you are giving some 1 milliampere as current. Okay, take some 5 kilo. So what is your output voltage? Anyone? I have given and I assumed 1 milliampere as input current, IS, and the trans conductance, right? Sorry, trans resistance. The gain for the voltage and feedback amplifier 5 kilo ohm. What is the output voltage? Output voltage 5. ஆடா மாடா கழுதையா குதிரையா?
5 volts, sir.
5 கிலோ வோல்ட்டா வோல்ட்டா?
Volt.
5 கிலோ வோல்ட் மாத்திட்டாங்களா? வோல்ட் தானா? சரி, ஓகே. How ma? So you know this formula, right? From this, where V out equals Rm times II, where I assumed Rm is 5 kilo ohm and I assumed this II is 1 milliamp, right? So 5 times 1 will give you 5. So is it making sense? Even though this gain, it has some unit, but we want to be in a position, okay, to find, to analyze all these things. Similarly, you can go with your own logic, okay, for current series feedback amplifier. Okay, so any doubt in the gain? Now my question, you know what is A? Do you know what is AF? And do you know what is A beta? Right? இது ஆல்ரெடி சொல்லி கொடுத்துருக்கேன். ஏங்கிறது ஓப்பன் லூப் கெயின் or gain without feedback, open loop gain. AF closed loop gain or gain with feedback. What is A beta? What is the name for A beta? Anyone can you remember? What is the name for A beta? It's very important.
Loop gain, sir.
Yeah, அப்படிலாம் கேட்கக்கூடாது. லூப் கெயின் தான் சரி, அவர் 6 டைம் சொல்லியிருப்பேன். Why is it so called loop gain? So what is the procedure to find loop gain? You want to make Vs equal to 0, input 0 or Is equal to 0. Okay, ரொம்ப சிம்பிளா சொல்லணும் அப்படின்னா, this is my simple structure, right? Feed forward, this is my feedback, this is A, this is beta, and here we are giving the input, right? Plus, minus. In order to find the loop gain, the procedure you want to make input as 0, it may be voltage or current. Now when you are traveling, okay, through this loop, this gain is A, this gain is beta, so it is called A beta. A beta is called loop gain. It's very important. So what is the unit for loop gain in all the 4 feedback topologies? That's what I am struggling to teach this point. What is the unit for loop gain? It's very important one time gate question. Unit for loop gain. You know the open loop gain unit, closed loop gain unit for all these 4 feedback topologies. Now unit for loop gain. Anyone? I have given everything. Just you want to think. That's it. For this topology, for voltage series, what is AV? V out time V out VI. What is beta? VF by V out. What is the unit I am asking? See, these two, right? Voltages, voltage cancel, voltage get cancel. So no unit. Similarly, come to voltage shunt. What's the unit? Voltage shunt. Here it is V out by II, A. Beta is IF by V out, right? I'm speaking about only quantity, sorry, only unit. Ampere get cancel, voltage get cancel. So here also no unit. Similarly, here also no unit, here also no unit. So conclusion, the unit of loop gain is no unit. Okay, it's unitless irrespective of feedback topologies. But the unit of gain, okay, is different. It based on this feedback topologies. That is the conclusion. Please make you know. Jump into it as well as a common exam point of view. It's very important. After that, we derived the gain, right? Closed loop gain. I think so. I derived it only for voltage series. Now I want to go with current shunt because voltage series la voltage sampling series mixing cover பண்ணிட்டேன். So inga current sampling shunt mixing cover பண்ணிட்டா I covered all the possibilities, right? So remaining two you can do by yourself. So put the heading to derive a closed loop gain for current series feedback. To derive, simply I am writing closed loop gain AF for current series feedback amplifier. You know, the closed loop gain, if you will derive automatically, you will get the open loop gain, okay, is divided by 1 plus A beta or multiplied by 1 over 1 plus A beta. That story you know, but anyway. So anyone, can you derive by yourself? Okay, so where you want to start? My, for this structure, my closed loop gain, output is current, input also current, but I out over IS. Okay, now by KCL, right, at input loop, what it says, your IS, right, that is my applied current, it is divided through II plus IF, right? Okay, therefore, and you know what is this guy? A out, sorry, I out. From this I out equal to A times V I out equals A times I, right? Since my A equals I out by II. So from this equation, what is your II? It is IS minus IF. So it becomes A times IS minus A times IF. This is my I out, right? Where IF from this relation, what is IF? Beta times I out. So A times IS minus A beta times I out. I'm looking for the ratio between I out to IS. So bring all I out to one side and IS to another side. Right. So I'm looking for the ratio I out by IS. That is my required closed loop gain. It is A over 1 plus A beta. So it's very simple. It's already we derived in EC2. EC2 என்ன டிஸ்கஸ் பண்ணுமோ அதான் பண்ணிக்கிட்டு இருக்கேன். Okay, general. I didn't start Kasavi's part, okay, in feedback amplifier. It will be quite interesting. By today's class, I want to complete the general, okay, discussion on general discussion on feedback amplifier. What we discussed in EC2. அதான் general discussion அப்படின்னு சொல்றேன். இதை முடிச்சிட்டு then later I will jump into Rasavi's feedback amplifier. Then you can compare both of things because இது புரிஞ்சாதான் அது ஈஸியா இருக்கும். So that's my aim. So by this way you can derive the closed loop gain for remaining two. Okay, I derived it for voltage series, current shunt. So I covered both the sampling as well as both mixing. So remaining two, voltage shunt as well as current series, you can do by yourself. Any doubt? Any doubt, ma?
No, sir.
Okay, the next actually I have given the formula alone, right, for input and output impedances. Okay, today we will derive it for the same voltage series and current shunt. Okay, so remaining two you will please derive by yourself. So you know the story, right? Input and output impedances, either it may increase or decrease. Yark increase, yark decrease. The story and all, you know. Now coming to current series, this is a general diagram, right? This is the general diagram for current series feedback amplifier. But this much, but this diagram, okay, is not enough, right, to find the voltage and to find the input and output impedances. For that, we are going to sketch the model for this voltage series. Not only for this voltage series, for all four feedback topologies, we are going to sketch the model. Okay, by using two-port network. It may be how we have done the small signal equivalent circuit diagram. அதே மாதிரி இதுக்கு just ஒரு model. In terms of circuits, இது எப்படி இருக்கும் அப்படின்னு discuss பண்ண போறோம். Okay, so listen me carefully. So I want to sketch input as well as output. Okay, as a two-port network for this feedback topology. Okay, coming to first, we will start from output. This is my first topology, voltage series. Okay, okay, I'm writing voltage series. So output is voltage sampling. Voltage sampling means what is my quantity? What is the output voltage? Output voltage is given by some gain. Let me call it as in general A times VI input voltage, right? So it is a voltage source, but this value is depends on input voltage. So this is called voltage controlled voltage source, and you know how to sketch. Okay, we have voltage controlled voltage source. Diamond symbol represents dependent source, plus minus this is a voltage source. Okay, the value is A times VI, where VI is the input voltage. That time being, just to hold on it, I will explain what is VI. But time being, I am concentrating on the output side. Okay, so this is a voltage source, voltage controlled voltage source. You know why? This is a symbol. So voltage source, it may have some internal resistance, right? It may have some internal resistance in series. Appa the output resistance jet out. Okay, and I am having this load resistance RL. So this is my output part where I am measuring my output. Any difficulty? Let me explain step by step. Then later you will get the clarity. So this is my output side. Coming to input side always this is my series mixing. Series mixing means can you apply KVL, right? Series mixing means KVL. You know it will give you Vs equals Vi plus Vf, right? So I am input side series mixing. So I want to connect voltage source Vs. Okay, okay. Then this Va. This is my Va, right? Input voltage. VA is the voltage across this. Actually, this is my VA, right? So it may have some internal resistance, this basic amplifier, right? That I can call it as ZI. Flow or current, the current through ZI is II. So now VA is the voltage across this basic amplifier. Okay. And I want to represent what is this final one? VF. VF is the feedback voltage, right? So it is a voltage source, VF. Since in order to satisfy this equation, எப்படி இருக்கணும் இது plus இது minus, this is my V. So this is the way to draw Thevenin and Norton equivalent. Actually voltage series means we have drawn the Thevenin equivalent. When we will be playing with the current, okay, we will be drawing Norton equivalent. So simply I am modeling, right, in order to find the input and output resistance. So this is the way to sketch for voltage series. Now can I go to straight away go to current shunt? Once if I will complete this, then for current series and voltage shunt, you can draw by yourself. That is the aim. So let me copy that current shunt feedback amplifier. Current shunt feedback amplifier. So this time I want to play with both are not on. My input is shunt mixing, output current, that is also okay, current source. Now listen me carefully. How to this first I want to start with as usual output. This time my output, right, output current I out equal to some gain times II. So I out equal to A times II. This is a current source since it is the output is a I out current. It is controlled by some input current. So this is called current controlled current source. And you know the symbol, right? Current controlled current source. Current source means arrow mark. Dependent source, right? Some books circle கொடுத்திருப்பாங்கமா, nothing wrong. But you want to be in a position, okay, to understand this is a dependent source. So this is A times IA, where IA is the input current that later we will take care of that. So this time current source அப்படின்னா it may have some internal resistance, but this time in parallel. And you want to sketch this R. This is my R. This is my output side. Coming to input side, this time shunt mixing IS. So this time you want to apply KCL. It will give you IS equals II plus IF, right? So this is my input side. This time shunt current mixing. So IS, all are parallel, right? This II, this basic amplifier, it may have some internal resistance. That is, Zi. The current which is flowing through this Zi is my II. The voltage, I can take it as some Vi, nothing wrong. Then actually Is equals Ia plus If, right? If is nothing but my feedback current that you can simply represent by a current source. So now apply KCL. This Is equals Ia plus If. So it satisfies. So this is the way. Any difficulty? Can you go for voltage shunt? Now take this. Thevenin and Norton equivalent we are drawing. Okay. This is also again not the original diagram. Just we are sketching it as a model. உள்ள என்ன இருக்கு எனக்கு இன்னும் தெரியாது. இன்னும் ஜென்ரலா தான் பார்த்துட்டு இருக்கேன் ஒரு ஃபீட்பேக் ஆம்பிளிஃபையர். Originally who is feedback amplifier, that really I don't know. Am I with you?
Yes, sir.
Okay. My phone is ringing. I don't know who is calling. But anyway. ஏன் அப்படின்னா அது பிஎஸ்என்எல் நம்பர் கால் பண்ணாங்கன்னா நெட்டு கட் ஆயிரும். அதனால தான் கேட்டேன். யாரும் ஒன்றும் இல்லை. அவங்க ஏர்டெல் நம்பர் கால் பண்ணாங்கன்னா ஏர்டெல்ல தான் நெட்டு கனெக்ட் ஆயிருக்கு. சப்போஸ் பிஎஸ்என்எல்ல கால் பண்ணி ஏர்டெல் நெட்டு கனெக்ட் ஆயிரும். அதனால தான் கேட்டேன். யாரும் ஒன்றும் இல்லை. சரியா? ஸோ ஏர்டெல்ல தான் கால் வந்திருக்கு. இட்ஸ் ஓகே. இப்போ புரிஞ்சாமா? வோல்டேஜ் சீரிஸ், கரண்ட் சண்ட். Now can you go for current series? Current series, right? So என்ன gain இருந்திருக்கும்? My output is current, but input is voltage. So some gain equal to output I out by Vi. So where I out equal to A times Vi. So this is a current source. Since my output is current, by input is voltage. So this is called voltage controlled current source. So voltage controlled current source. Current source A times Vi controlled by some input voltage that later we will take care of that. But since it is a current source, அப்போ இதுக்கு parallel ஒரு jet out. So parallel ஒரு finally R. And coming to input side, series mixing. Series mixing means you want to apply KVL. So Vs equals, Vi plus Vf. That story, This is my Vi, internal resistance of this. Okay, this is my Vf. This is plus, this is minus. So this is my current series. Fourth one, voltage shunt, right? So once if you know the logic, then anytime you can recollect it. நான் இப்போ எதையெல்லாம் படிக்கல ஜஸ்ட் ஹவ் ஐ ஆம் சொல்லாத ஒரு 4 டைம் எடுத்துட்டேன் அப்படின்னு தட் ஐ நோ 4 டைம் எடுத்தாலும் கான்செப்ட் லாஜிக் வரணும்ல ஹவ் ஐ ஆம் ரீகலெக்டிங் ஆல் திஸ் ஜஸ்ட் பை know the logic. So voltage shunt. So this time my output is voltage, input is current. So output is voltage, input is current. This some gain. So where V out equal to A times II, output is voltage quantity. So it is a voltage source. It is controlled by some input current. So this is called current controlled voltage source. Current controlled voltage source. So voltage source, plus minus. Okay. And it is controlled by some input current. So this is voltage source of the series of some jet out இருக்கும். And here it is my RL. Okay, coming to input side, this time shunt mixing. Shunt mixing, you want to apply KCL. You want to remember this logic: IS input current equal to IS plus IF, II plus IF. So this is my IS basic amplifier. It may have some internal resistance Zi. The current through this is IA, and this is my IF. So this is the way to draw the Norton and Thevenin equivalent for voltage shunt. So any doubt in sketching these 4 models of feedback topologies?
No, sir.
So what's the time remaining?
15 minutes இருக்கு சார்.
Okay, so I will derive the input and output resistance of voltage series feedback amplifier first. Okay, so jet IF, right? Input impedance with the feedback and output impedance with the feedback. Okay, for voltage series feedback amplifier. Quickly, I want to draw the equivalent circuit, right? I want to draw the model for voltage series. So voltage series அப்படின்னா outputல யார் இருப்பா? I believe this is my A times VI. So voltage source series இருக்கும். And finally I want to connect this RL jet out plus minus input side series mixing. So I want to go with VS. This is my jet I where this current is IA. So this is my VI and this is my VF plus minus. So this is circuit diagram, right? This is a model for voltage series. Now let me put the heading A to find input impedance with the feedback. Okay, what is the expected answer? Anyone? What's the expected final expression? Input impedance for voltage series feedback amplifier. Series mixing. So input impedance increases or decreases?
Increases.
Increases by a factor of, so input impedance Zi by a factor of 1 plus A beta. So you want to, we are expecting this expression. Let's hope. Okay. And what is my input? So see, this is Paltre, right? Tall guy. He's standing here, right? When I'm standing here, நான் இங்க இருந்து பாக்குறப்ப என் கண்ணுக்கு ரெசிஸ்டன்ஸா யாரு தெரியுமா? You know what is RI, right? Input impedance Zi. This time with the feedback. Simply what is R? The ratio between as per Ohm's law, V to I. V to I. Here V is என் கண்ணுக்கு தெரிகிற voltage source Vs, என் கண்ணுக்கு தெரிகிற I வந்து IA. So I want to find the ratio between Vs and IA. That will give you my input impedance with feedback, right? So I can write jet IF equals Vs by II. Okay, where what is Vs? As per KCL, apply KVL at input loop. So Vs, that a lot of time we have come across this equation, Vs equal to Vi plus Vf. Therefore, my input impedance with this is Vs, Vi plus Vf divided by Ia. Okay. Okay. What is my Vf? What is the value for Vf in voltage series feedback amplifier? What is this value for Vf in voltage series feedback amplifier? Anyone?
Beta
Yes.
Vinox.
Beta times V out. Thank you. So this is Vi plus beta times V out divided by Ia. Since Vf equal to beta times V out. Okay. Am I with you, right? Okay. Then what is my Ia? Sorry, Vi. Okay. Do one thing. Keep V as it is. Beta times. What is V out in voltage series feedback amplifier? This is my V out, right? V out equal to A times Va.
AVA.
So just substitute that. A times Va. For this, since this V out equal to A times Va. இந்த ரெண்டுமே எங்க இருக்கும் அப்படின்னா feed forward as well as feedback network of voltage series. இதுல பார்த்தீங்கன்னா you can find V out. இதுல பார்த்தீங்கன்னா you can find VF. Okay, அந்த ரெண்டு ஈக்குவேஷன் தான் இங்க எழுதுறோம். Nothing new. Okay, this is my IA. So take VI as common. So VI times 1 plus A beta by II. This is my jet IF. Okay, who is V out? VI by II?
ZI.
VI by IA, that is nothing but my jet I. So jet I times 1 plus A beta. This is my input impedance with the feedback. This is what we expected, right? So very simple. So I repeat the procedure, I repeat the steps. Okay. So input resistance, நீங்க இருந்து பார்க்கறப்போ கண்ணுக்கு தெரியுற voltage source Vs, கண்ணுக்கு தெரியுற current IA. So you want to find the ratio between Vs to IA. அப்போ Vs to IA ன்னு எழுதுறேன். இல்ல எனக்கு Vs தெரியும். Since I am playing with voltage mixing, so Vs equal to Vi V plus Vf. By Va plus Vf. அப்புறம் I am playing with Vf feedback networkல. அதுல beta times V out. அதுல I am playing with V out from feed forward networkல. இந்த ரெண்டையும் substitute பண்ணிட்டேன்னா you will end up with the expected answer. Okay. So quickly I want to find the output impedance also for this voltage series feedback amplifier. Okay. What is the procedure to calculate output resistance? Anyone? அது ஒரு 1 மார்க்கா கேட்டிருந்தேன். ஆக்சுவலி மொத்தமே 3 டாபிக் தான். கேஸ் கோட் ஆம்பிளிஃபையர், டிஃபரன்ஷியல் பேர், ஃபீட்பேக் ஆம்பிளிஃபையர்லையும் ஜஸ்ட் வந்துட்டு only I completed that gain with feedback, closed loop gain, அப்புறம் இன்புட் அவுட்புட் இம்பிடன்ஸ். இதை வச்சு எப்படா ஒரு 45 கொஸ்டின் எடுக்கணும்? திங்க் அபவுட் மீ. ஸோ இட் வாஸ் வெரி டிஃபிகல்ட், ரைட்? அப்படிதான் நினைச்சிட்டு இருந்தேன். பட் நோட்ஸ் எடுத்துட்டு மைண்ட்ல உட்காந்து யோசிச்சப்ப அப்படியே வரிசை என்னென்ன நடத்துனேன்னு அப்படியே யோசிச்சு ஒவ்வொரு கொஸ்டினா எழுதிட்டு பார்த்தா 46 கொஸ்டின் வந்துச்சு. தேங்க். ஸோ ஒரு 3 டாபிக்ல 46 கொஸ்டின் எடுக்கணும் அப்படின்னா ஜஸ்ட் திங்க் இப்போ எவ்வளோ டெப்தா நம்ம படிச்சிருக்கோம் அப்படின்னு. ஸோ ஃபார் தட் ஐ ஆம் ஹாப்பி அண்ட் ஐ என்ஜாய்ட் தட் questions when I was taking. I believe you enjoyed. Okay, your exam also. என்ன ஓப்பன் புக் டெஸ்ட், புக் இல்லாமல் எல்லாம் நல்லா இருந்திருக்கும். பட் நீ எல்லாம் பண்ணியிருக்க மாட்டேன் யாரும். ஓகே, இதுக்கான ஆன்சர் பண்ணி பார்க்கலாம். What is the
Opening the
procedure?
load and by applying the test signals. Sir.
You want to open the load, okay, and you want to apply the test signal.
And
So
the ratio would give the
okay.
resistance out.
So this time B, subdivision B, to find output resistance, jet out with the feedback. Okay, so let me quickly roughly draw that model. Is A times Vi plus minus. Here I am having some jet out. and this is my RL. Roughly I am sketching, and this is my VS. This is my VI. Here I'm having my VF plus minus plus minus. Okay. So what is the procedure? As you told, you want to open the load. Yeah, I am opening the load. அவ்வளவுதானாமா? You want to open the load and you want to apply
Sir,
the
I
test
said
signal.
applying the test signal. And
Okay,
the
test signal.
அதுக்கப்புறம்
Vx.
அதோட ratio would give the resistance.
That's it.
Vx by X would be
Ah,
resistance.
so what is your output resistance when you are looking from here? இப்போ இங்க இருந்து பார்க்கறப்ப பாத்தீங்கன்னா my output resistance, right? Nothing but my jet out f. It is Vx over Ix. That's it. வேற ஏதாவது பாயிண்ட் மிஸ் ஆயிருக்கா? ஐ எம் எக்ஸ்பெக்டிங் ஃபார் ஒன் மோர் பாயிண்ட். நானே சொல்றேன். ஒரே ஒரு பாயிண்ட் இங்க மிஸ் ஆயிருக்கு. என்னது? In order to find Thevenin resistance, you want to kill all the independent sources, right? So that is the very first point. Then open the load, then okay. So you want to make actually Vs equal to 0. You want to kill means you want to replace voltage source by short circuit, current source by open circuit. So if Vs equal to 0, if Vs equal to 0, we know one equation. What is Vs? By applying KVL at the input loop, Vs equal to Vi plus Vf, which means 0 equals Vi plus Vf. So from this I am finding Vi equals minus Vf. Okay, so this relation will help. So very first step, you want to kill all the independent sources. Okay, replace voltage source by short circuit, current source by open circuit. Then open the load, apply a test signal Vx. Because of that the current is Ix. Now find the ratio between Vx and Ix. That will give you the output resistance with the feedback. Okay, so now coming to this. Okay, so now this time you know jet OF equal to Vx over Ix. What is Vx? Apply KVL at output loop. Apply KVL at output loop. Before that, I want to write the final expression. You know, feedback, right? Output impedance with the feedback for voltage series. So sampling, voltage sampling, resistance increase or decrease? Decreases by a factor of 1 plus A beta. So we are expecting this formula, this expression, right? Okay. Now apply KVL at output loop. I am applying Vx, that is dropped across Z2O. Here the current is take I out. So jet out times I out, right? This voltage plus minus, and this voltage A times V. Okay. Time being take this is VO. Right? Okay. So I'm looking for the ratio VO to IO. Okay. So what's the next step? Any idea? So this is jet out IO plus A times what is VI? Where VI equal to minus VF. So it becomes minus VF. This is my VF. Now bring that minus VF to the left hand side. It becomes A times VF jet out IO. Where you know what is VF? What is the formula for VF? It is beta times V out. This is also V out equal jet out times V out. Take V out as common. It becomes 1 plus A beta. It becomes jet out I out. We are looking for the ratio between V out to I out. V out and I out. That is my required output resistance with feedback, which equals jet out over 1 plus A beta. So this is what we were expecting, right? So just apply the procedure, kill all the independent sources, open the load, and apply the test signal. Okay. MCQல அந்த பாயிண்ட கொடுக்க முடியலம்மா, அது அவ்வளவு பெருசா இருக்கும், அதனால எழுத முடியல. அதனால வந்துட்டு சிம்பிளா வந்துட்டு அப்ளை ஓபன் த லோட் அண்ட் அப்ளை த டெஸ்ட் சிக்னல் கொடுத்தேன்.
Okay, sir.
What's the time? Time up. Yeah. Okay. Thank you. we will derive, okay, the input output resistance for current shunt. Voltage series முடிச்சிட்டேன். So I want to go with the current shunt. So remaining two you can derive by yourself. அப்படிதான் சொல்லணும். அப்ப நான் derive பண்ணிடுறேன். அது ஒரு விஷயம். அதுக்கப்புறம் we will start, okay, how to identify the topology. அதுக்கப்புறம் ப்ராப்பர்ட்டி இதெல்லாம் முடிச்சா இதெல்லாம் ஈஸி டூல் நம்ம முடிச்சது. ஓகே, ஐ வில் ஃபார்வர்ட் மை ஈஸி டூ மெட்டீரியல் ஃபார் யூ பீப்புள். இட் வில் ஹெல்ப் யூ ஃபார் யுவர் CMOS as well as for your job interview. And I believe you might have hold my material, right? I believe ஈஸி டூல ஃபர்ஸ்ட் யூனிட்ல ஃபீட்பேக் ஆம்பிளிஃபையர் நான் தான் நடத்திட்டு இருக்கேன். புதுசாக ஒன்றுமே நடத்தல. ஓகே, ஐ வில் ஃபார்வர்ட் இட் ஒன் மோர் டைம். டோன்ட் வரி. ஸோ தேங்க்யூ. டைம் முடிஞ்சல 10:45 to 11:35. 5 நிமிஷம், 2 minutes, 1 minute இருக்கு. சரி பரவாயில்ல. ஓகே, if time permits, please try to derive, okay, the input output resistance for the remaining 3 feedback topologies, namely voltage shunt, current series, and current shunt. So any doubt, those who are having doubts, you may stay. Otherwise, you can leave. Thank you. Thanks for your attention.
Sir, and